this section we can continue on and now look at the law of cosines. Law of sines has a law. Cosines kind of feeling left out. So let's look at that and see how they can be useful and helpful to us. So let's begin with this. Let's figure out where the law of cosines comes from. So I have a triangle on the board that I want to kind of begin starting with. I aligned it with the coordinate plane. So I have points A, B, and C, and lengths A, B, and C. I know that this point I situated on the origin, so I have the point 0, 0. Point B, it's at a distance C away, so its coordinates are C and 0. And then likewise, I have some coordinate C somewhere up with a coordinate X and a Y. So, and then I dropped an altitude with a Y variable in there as well. Just let me know what that height is. So let's look at a couple of thoughts and let's just begin this derivation. So I want to figure out what the cosine of A is. Cosine of A was adjacent over hypotenuse. Cosine of A, so it's this triangle right here, it's adjacent. Since this length right here is an X, that would be X over B. And I want to solve that for X. X equals B times the cosine of A. Likewise, I want to write some type of trigonometric identity in terms of Y. So let's look at the sine of A. Sine of A was its opposite over hypotenuse. So A opposite is Y over hypotenuse is Y over B. Solve that in terms of Y. Y equals B times the sine of A. So what I was able to do is to rewrite X and Y in terms of some trigonometric identities. So what that helps me do now is that I can look at this mark right here, X and Y, in terms of B cosine A and B sine of A. I want to find the distance between those 2 points. And I have to remember what the distance formula was. Distance formula, one point minus the other point, x minus c squared, plus the other point, in this case, is y minus 0 squared. So that was our distance formula. Distance between one point here and another point. Those are the 2 points that I'm going to use. Let's go ahead and start to clean this up a little bit and see where it leads. I'm going to square both sides, and that gives me x minus c squared plus y squared. I was able to rewrite this x and the y in terms of something else. So let's go ahead and include that b over cosine A. Yes, I agree. It's looking like it's getting ugly, but it's going to go someplace that we're going to find is useful. All right, let's square both sides, or square this term right here. So I have a squared. It's going to get long here. So I have b squared cosine squared of A minus 2 times b times c times the cosine of A plus c squared. That was multiplying that times itself, plus b squared and sine squared of A. All right, just take a moment, pause. Take a deep breath. Okay, next step, I'm going to just rearrange it. No, not yet. I'm going to bring this term over next. In these first 2 terms, I see a b squared. I'm going to factor that out just in the first 2 terms. And then I'm left with a cosine squared of A plus a sine squared of A minus 2bc cosine of A. Oh, I forgot one thing. I dropped it. The c squared comes along too, so I need to bring the c squared down. I dropped it. Let's put a c squared there. Let's put a c squared right there. Just carry that c squared all the way down. Next, this cosine squared of a plus sine squared of a, do you remember what that equals? That's just 1. So this kind of cancels out. So I'm left with a b squared plus a c squared minus 2bc cosine of a. And this right here gives me one of the 3 cosine or law of cosines. To develop the other 2 are just in terms of for b squared to c squared, follows the same derivation, and on the next couple of videos I'll put those up on the right side, or on your right side, my left side as well, but they follow the same process. And again, I hope you think it's kind of fascinating, kind of cool that we can manipulate things around based on the tools and the rules that we have to get to something else that will be useful. And why is the law of cosines useful? It's going to help us solve some triangles where the law of sines cannot. So I'm going to show you 2 examples coming up.